So I'm sure all of you have been asked to write hypotheses before or state hypotheses. What do you know about hypotheses already? An educated guess. Okay? And that's probably, you've been learning that, using that same definition since 5th grade. Okay? Maybe before that. I just know that there's a good bit of chemistry in the 5th grade science standards, in this state anyway. And a hypothesis is, in its broadest sense, an educated guess. But if that's all you've ever done with it, you probably don't really understand what it means to a scientist, okay? And so we're going to refine this understanding of what an hypothesis is in here, okay? It is not just an educated guess, all right? An educated guess is, in broadest sense, what it could be. But for use in the sciences, you need some more guidelines. You need to refine it a bit further, okay, on what the educated guess is, all right? Now, I mentioned this when I was talking about graphs. I said that a hypothesis would be stated if then, okay? So to use an hypothesis effectively when you're doing any kind of scientific research, you need an if-then statement, okay? So hypotheses have to be in if-then form to be practical, all right? And that's what they're required. That is what is required in here, if-then form. If-then form, okay? And what I mean by that is, if I do A, then I expect B to occur. Does that make sense? So, if I were to throw a smoke bomb in the middle of this room, then I would expect everybody to scream and run out of the room. Okay, that's kind of the idea. Got that? Or, if I were to put water in a beaker on the lab table and put it on a hot plate and turn on the heat, what would I expect the water temperature to do? Well, it would increase the temperature until it reaches boiling. That's true. Okay, so if I heat up the water, then I expect the water temperature to go up. Now, you may not quite understand the difference between heat and temperature right now, but there is a big difference between heat and temperature. Okay? If I add baking soda to vinegar, then I expect what to happen? Bubbles. Okay? I thought maybe most of you would know that. Y'all know that? You get bubbles? No? Okay, that's a pretty common, elementary school demonstration or test that's done. Huh?
Volcanoes.
Well, yeah. People make volcano stuff out of it like that, right? Okay? And all of those are if-then forms. But even that's not enough. Okay? Because what's important to a scientist is why that happens. Okay? Science is not just about what happens. It's about how things happen, in the sense that what is going on that you can't see that makes it happen. Okay? I sometimes say it's the why. Some people who are smarter than me about the nature of science have a problem with the word why, because the way that they think about it, the word why implies some kind of reasoned action behind it making it happen. That there is some mystical, metaphysical power that makes the vinegar and baking soda react to make bubbles. Okay, and that's not what the why in this case means. It means that the why is we get bubbles because of the chemical reaction that creates a gas. Okay, that's what we mean by the why. That makes sense? Okay, so when I say why, I'm not talking about gremlins causing it to happen. Okay, got it? Yeah, or some metaphysical higher power making it happen. I'm talking about what is going on with those atoms and those molecules and things like that that are causing it to happen. Okay, the cause is another thing that some people who are smarter than me have a problem with. Cause implies, to them at least, that there is some kind of a power beyond the physical making it happen. And I'm talking about, when I say a cause, I'm not talking about that. I'm talking about what is it that's happening that you can't see that would make it happen. That clear? Everybody understand that? Okay. So, but the problem is when I use the word how it happens, well, for high school students, very often they think that means, well, it happened because I put the baking soda in the vinegar. That's the how. But that's not the how we're talking about here. So we have a terminology problem, and I'm trying to help you guys and hoping your guys are going to grasp the deeper meaning we're talking about here. Okay? With us, we want to know what's going on that we can't see but might make it happen. And that's what science is about. Science is about trying to figure out these things. Okay? What would cause it to happen, but not a metaphysical cause, but a physical cause. That makes sense? Okay? So, when we write an hypothesis, then, we not only need this if-then form, but we also need, either as part of the hypothesis statement or as an adjoining statement, what we think would cause that. Okay? So if I were to write an hypothesis about vinegar and baking soda, I might say, if I increase the amount of baking soda I add to this beaker of vinegar, then I would expect more bubbles to occur because there is a chemical reaction that's creating a gas. Does that make sense? So the because part of that is what we're talking about. What is making it happen? Because. The cause. That makes sense? All right? So if you want to write because, that's a really good way to make sure you remember to write that. So not just if-then form, but if-then because. All right? And the because, like I said, can be a separate statement if you need to. Sometimes that statement might come right before it. Sometimes it might come right after it, but it needs to be right there with it somewhere so it's clear that it's part of the whole thought process of what the hypothesis is about. Make sense? All right. And you sound like just talking to you guys and kind of pulling it out of you. You already know what independent and dependent variables are. We're clear with that? Okay. So the if part of the statement then is the independent variable. Okay. If I do A, well, that's the independent variable. That's what you change. The independent variable is the part of the experiment that you change. And as I said when we're talking about graphs, that is the part that you might have called in another class the manipulated variable. Okay, and the then part of the hypothesis statement is the responding variable in that earlier terminology, what we call in this class the dependent variable. Okay, independent variable is if, dependent variable is then. And so all this stuff is kind of tying together here. Not only are hypotheses in this sort of form where what is happening in the independent variable affecting the dependent variable, but so is the title on the graph saying that too. That makes sense? But you can't really tell how the independent variable is affecting the dependent variable very often unless you graph it. Now you might be able to tell from the table if you're really slick and kind of figure out the pattern. You can kind of see it happening, but you can't often tell if it's a straight line or if it's a curve that just kind of goes up but curves over a little bit or something. Okay, if it's not a straight line, you wouldn't be able to tell just by looking at the numbers unless you're way smarter than me. And you might be, but we need the graphs to figure that out. And that's why graphs are tools for analysis. Okay? So all these things are going to fit together here. All right? If you get all the little pieces together, it's all kind of adding up to the same stuff. But it's not just enough to know what is happening. We're trying to figure out, if it's possible to do so, what might be the most reasonable cause. Now, there's that term reasonable we've talked about before. Okay? It's not just for sure this is what's happening. And sometimes in the sciences, I might even say, it may make it sound like this is for sure what's happening. But in fact, it may not be for sure. Okay? It just seems like that's what's reasonable. Okay? Make sense? You with me? All right. Okay, so I know this was a little hard to read, but we have students here giving some examples of hypotheses to see if we can kind of sort out how well you've got a grasp on what an hypothesis ought to be. So if you fight in school, then you will get in trouble because it's against the rules. Okay? So that's the if-then form. All right? And clearly, the if-then part, the if part of it, is going to affect the then part of it because it's against the rules. Now, that's good insofar as it goes. The only thing we don't have here is a true variable. Okay? Because this is, a variable means there has to be some measurable change. That makes sense? So if you fight, that's a one data point thing. Okay? You can't plot that on a number line. All right? Now, you might revise this a bit to talk about the increasing trouble you get into, at school, and then you might have multiple data points. Does that make sense? That is to say, the first time you fight, you get in trouble like this. The second time you fight, you get in trouble like that. And while that wouldn't give us a true dot graph form, we'd probably have more of a bar graph kind of form. It still would give us an independent dependent variable, a true variable. Does that make sense to you? Okay. So this is a good first idea. You kind of got the if-then part down here and the because part, and that's good. All right. Let's see what the next one is then. If the temperature in the school is too hot, then students get irritable because it gets uncomfortable. Okay, and that's if-then, and you got the because part, so the model's there. That's all really good. Okay, but it just says too hot. Too hot is a single data point. Okay. On the other hand, if you were to state this as if the temperature rises increasingly above this point, okay, say 22 degrees centigrade is roughly room temperature. So as the temperature rises increasingly above 22 degrees centigrade, then there will be more fights in the school, for example, irritable, right? All right. That'd be a good data. You'd have multiple data points, wouldn't you? On both the independent and dependent variables. Okay? So it might be some other kind of irritation you're looking at. All right? You might just be looking at the number of people's kids get written up or sent to ISS or whatever. All right? You can measure that. That would be a measurable difference. All right? And that might actually be a pretty good thing to do. That'd be a good experiment, wouldn't it? Good sociological experiment to do. Okay? Huh? I don't even know what that was. Okay. Oh, I know what it is. My YouTube video is starting to play without me telling it to go. All right, we'll stop that. Okay. All right. That's good. Let's see here. If the fire alarm goes off, then people evacuate the premises because there was a signal of fire. All right. Again, we don't have a true variable here. Still, we have the if-then form. You got that part right. That's good. Obviously, the independent variable or the independent data point is affecting the dependent data point. But and the reason for it was the signal of the fire. Could be more explicit about that. Okay, this is a good place to start though. But we don't really have true variables here yet. Does that make sense to you? Got to have variables. Okay, if we're actually going to use them in an effective way in the sciences. All right. If the Cavs Express decreases, here we got a variable. If the Cavs Express decreases its prices, decreasing meaning going down, so we got multiple data points here. We actually have a number line that's changing. Then more students will buy things, so we can count the number of students buying things. Okay, we can count their profit or whatever, because they are more likely to afford those things. Okay, there we got a really good hypothesis. That makes sense? That would be something you'd actually test. It would have a whole number line on both the independent variable and dependent variable. That makes sense? We can find out if it's true. All right, but the problem is the more you drop the prices, then the less profit they make, and the thing might not be able to keep in business. Anyway, that's another issue for another time. All right, now here's another fire alarm issue. Okay, that's kind of the same thing we talked about before. Yes, single data points. All right. If the teacher is sick, we got some hopeful thinking going on here. What's the deal? Then the class will be assigned a substitute. Okay, if then, that's true, because the teacher is not present to teach. Well, if probably has to do with somebody having to be here for you, but that's okay. All right. So be careful about your because statement. All right. Make sure there's a clear. The phrase is causal link. Causal link. Okay. When you're writing this because statement, you need to be clear about what is the cause. What is the cause of the independent variable changing the dependent variable in some fashion? Okay? So the word is causal, or the phrase is causal link. Another word for that is causality. Okay? You can say, for example, and this is like my favorite example, the cancer rate in the United States is the highest in the world. There are also more telephone poles in the United States than the rest of the world. Therefore, telephone poles cause cancer. Yeah, I see somebody. Yeah, you're good. I like that. Okay, y'all didn't see your face, but I saw. You're right. That's not true. That doesn't make any sense, does it? Is that a real causal link? No. There's an association between the two data points, but does one really cause the other? See, when you write a because statement, you want to make sure you're writing it in a way that makes it reasonable that there is a causality there. there is a causal link. Does that make sense? All right. Good job, guys. Okay, you know what you got to do for Monday, right? Research on that debate, all right, discussion we're going to have. All right. There's no limit on the upper limit, but you need, I would think, at least 5. Okay, let's put an lower limit of 5. Okay.